So we are going to begin the second topic of the chapter 4, that is the general concepts of instruction execution cycle. If we talk about the basic microcomputer design, the central processing unit, the CPU, which is responsible for the calculation and the logic operations, takes place, and it also contains a limited number of the storage locations. It is named as registers, a high frequency clock, a control unit, and an arithmetic and logical unit. We are aware of this point that arithmetic and logical unit is responsible for the various arithmetic operations like addition, division, and or not, etc. The operations are performed in the arithmetic and logical unit, and the registers are used for the storage of various types of locations where the instructions have to be fetched, decoded, and executed. If we talk about the clock, we know that the clock is responsible for the synchronization of the internal operations of the CPU with the other system components, like the control unit that coordinates the sequencing of the steps that are involved in the executing of machine instructions. So control unit is what? It is the unit that is responsible for the whole control of the CPU, and it is responsible for the instructions providing and making the system in a smooth state by taking all controls in itself. So from where the data will be fetched to where the data will be stored and how the data will be placed, this all is controlled by the control unit. If we talk about the next point, that is ALU, we have known that the ALU stands for Arithmetic and Logical Unit that performs arithmetic operations such as addition, subtraction, and the logical operations such as AND or NOT. If we look at the diagram, we can see the basic things are CPU, which is consisting of ALU, that was Arithmetic and Logical Control Unit, second was Control Unit, and the third was Clock. We can also see there is a control bus, an address bus, and data bus, which have their specific assigned tasks to complete. There is a memory storage unit, and there is input output devices 1, 2, or they can be up to n. It is depending on the process. So while now we move to the next slide, that is memory storage unit. We can see the memory storage unit is where the instructions and data are held while a computer program is running. If we talk about the bus, what is bus basically? It is a group of the parallel wires that transfers the data from one part of the computer to another, and a computer system bus usually consists of their separate buses. It implies they can be data bus, address bus, etc. So if we talk about the control bus uses the binary signals that synchronize the actions of all the devices attached to the system bus. If we talk about the address bus holds the addresses of instructions and data when the currently executing instruction that transfers the data between the CPU and memory. If we talk about the clock, the each of and every operation that is involving the CPU and the system bus is synchronized by an internal clock which is pulsing at a constant rate. So the basic unit of the time for the machine instruction is a machine cycle, or also known as the clock cycle. So they can see on the 0 it is lying down, and for the 1 it is moving upward. We can see that how a cycle is operating with the clock. So what is the clock doing? A clock that oscillates 1 billion times per second, that is almost equal to 1 gigahertz. For example, it produces a clock cycle with a duration of 1 billion of a second, or it is equal to 1 nanosecond. A machine instruction that is required at least one cycle to execute, and a few requires in the excess of 50 clocks of instructions. The instructions that are requiring the memory access often have the empty clocks called as the wait states because of the differences in the speed of the CPU, the system bus, and memory circuit. So this is the basic thing about the computer architecture subject. So if we move towards the instruction execution cycle, the execution of a single machine instruction can be divided into a sequence of individual operations called as the instruction execution cycle. Each of the steps is described as the fetching is what the control unit that fetches the instruction from the instruction queue and increments the instruction pointer. So, while the execution of instruction will take place, the value of instruction pointer will keep on increasing or incrementing. So, the instruction queue that holds a group of instructions about to be executed, the instruction is also known as the program counter. The instruction pointer contains the address of the next instruction. So, the decoding is what it is. We have already studied these stages. Simply reading out here, the decoding is what the control unit that decodes the instructions function to determine what the instruction will do. What is the fetching operand at the instruction uses an input operand which is located in the memory and the control unit that uses a read operation to drive the operand and copy it into the internal registers. What is the execute stage? The ALU that executes the instruction using the named registers and internal registers as the operands and sends the output to the named registers and or memory. So the ALU that updates the status flags providing the information about the processor rate and store the output operand. If the output operand is in the memory, the control unit uses a write operation for the storage of data. So the sequence of the steps that can be expressed neatly in the pseudocode loop fetching the next instruction advance the instruction print pointer to decode the instruction. If the memory operand is required, then the read value is there from the memory that executes the instruction. If the result is memory operand, then the write of result to the memory that is continued in the loop and the non-pipeline suppose for the each execution state in the processor that requires a single clock typing. We can also see from the diagram there is memory, registers, ALU, flags, decoding, fetching, executing. These are the stages. Registers are there. The program is there for the fetching and the computer is defined as I-1, I-2, I-3, I-4. These are the stages or the values that will keep on incrementing and the memory is consisting of the operands, operand 1, operand 2. Writing is done into the registers in the memories which is connected to the ALU. The flags are there, the execution stage is there. So the diagram is defining itself. So this was the concept of today in which we have learned the instruction execution cycle. In the next topic, we will study further. Thank you.